In this video, I will illustrate how we can apply the AMGM inequality to solve this problem from the 19th Philippine Math Olympiad qualifying stage. So the problem states, if b is greater than 1, find the minimum value of 9b squared minus 18b plus 13, all divided by b minus 1. Before we proceed to the solution, let us recall first what we mean by the AMGM inequality. So the arithmetic mean, geometric mean, or the AMGM inequality states that for a collection of n non-negative real numbers a sub 1, a sub 2, a sub 3 up to a sub n, the average of the numbers a sub 1, a sub 2, a sub 3 up to a sub n is greater than or equal to the nth root of their product, with equality if and only if the numbers a sub 1, a sub 2 up to a sub n are equal to one another. Okay, so now if you notice, it's not yet clear how we can apply the GM inequality. If you are in that situation, I suggest that you manipulate first the given expression to see what happens, or to get a feel of the given expression. Now, I noticed that in the given expression, if we split 13 into 9 plus 4, we can actually factor out 9 from the first three terms and then get a perfect square trinomial. So 9b squared minus 18b plus 13 all divided by b minus 1 can be written as 9b squared minus 18b plus 9 plus 4 divided by b minus 1. Now, why did I do this? Because if we group this, we can factor out 9, and then we get 9b squared, 9 times b squared minus 2b plus 1, okay, plus 4, all divided by b minus 1. Now I can write b squared minus 2b plus 1 into b minus 1 squared. So we have 9 times b minus 1 squared. Okay, now if I split the expression into 9 times b minus 1 squared over b minus 1 plus 4 over b minus 1, I can cancel b minus 1, so that we get 9 times b minus 1 plus 4 over b minus 1. Okay, so this form is actually good, because if we treat this number as a sub 1, this number as a sub 2, and then follow the AMGM inequality, we eliminate the variable b in the right hand side, because take note, we will just multiply these two numbers, right? And so the numerator and denominator will have a common factor of b minus 1, so we can cancel that, and we are left with a constant in the right hand side. Okay, now let's apply the AMGM inequality. So now, instead of using this, we used its equivalent, which is 9 times b minus 1 plus 4 over b minus 1. Now if we get the average according to the AMGM inequality, this is greater than or equal to the square root of the product of the two numbers. By the way, you have to make sure that the two numbers are non-negative. Now let's check first. So actually, we're sure that this one is greater than 0, this one is also greater than 0, since b is greater than 1. Okay, so we can apply the AMGM inequality. Now let's proceed to the next step. We have 9 times b minus 1 plus 4 over b minus 1. Now we can cancel b minus 1, so we have in the right hand side the square root of 36. Square root of 36, that's 6. So if we multiply both sides by 2, we have 9 times b minus 1 plus 4 over b minus 1 greater than or equal to 12. Okay, so this one suggests that the minimum value is 12. But, okay, so minimum value of 9b squared minus 18b plus 13 over b minus 1 is 12. But we have to check for which value of b 12 is attainable, or the minimum value of 12 is attainable. To do this, let's go back to the EMGM inequality, the description of the EMGM inequality. How can we do this? So take note, equality holds if a sub 1 equals a sub 2, a sub 2 equals a sub 3, and so on. So to get the value of b for which 12 is attainable, we have to equate 9 times b minus 1 to 4 over b minus 1. I'm doing this because I want to check whether 12 is really attainable. And for many problems of this type, you have to do this. Okay, now if I multiply both sides by b minus 1, I have 9 times b minus 1 squared equals 4. So b minus 1 squared equals 4 over 9. And so if we get the square root of both sides, we should take only the principal root since b minus 1 is greater than 0. So b minus 1 equals 2 over 3. And so b must be equal to 1 plus 2/3 or 5 over 3. Indeed, this one is attainable when b is equal to 5 over 3. So now we are sure that the minimum value of the expression 9b squared minus 18b plus 13 over b minus 1 is 12.